This will be a 10-minute hold extending until 7:24 a.m. And when the countdown resumes, the ground launch sequencer will be in control. This master computer program will issue the commands to perform the final critical tasks required to put the vehicle in the final launch configuration. And it will also monitor as many as 1,000 different measurements during the final 9 minutes to make sure that they do not fall out of predetermined limits. All personnel in Firing Room 3 have been asked by the Lockheed Test Director, Chuck Hannon, to switch over to the same communications channel, and they'll remain on that channel from now through liftoff. T-minus 9 minutes in holding. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 9 minutes in holding. We have a number of distinguished guests with us this morning up on the roof of the Launch Control Center. These include a number of guests from the Arabsat nations, include some of the distinguished guests from Mexico that are here to see their Morelos satellite lifted up into orbit. Here in the Launch Control Center, we are completing the final poll of systems engineers here. NASA Test Director Frank Merlino conducting that poll, receiving a go for launch from the various systems engineers: vehicle, spacecraft, range, MILA, mission control. We have gotten a final clear to go from the range safety officer. And also in the, of course, in the group of distinguished guests and visitors that we have with us include members of the French group that are here to see their payload specialist, Patrick Baudry, make his flight aboard Orbital Discovery and Mission 51G. All systems are reported go at this point. Shuttle project engineer Gene Thomas has reported from the integration console that everything looks very good, and we should be picking up the countdown here shortly. Several major milestones remain between now and launch. As we come out of the hold, the ground launch sequencer, which is the master computer program running in the integration console, located in the firing room, will take over command of the remaining events, as well as monitoring the response and status of other vehicle systems. At T-minus 7 minutes and 30 seconds, the orbiter access arm will be retracted, and at T-minus 5 minutes, Pilot Creighton will throw cockpit switches that will start the auxiliary power units. We will terminate liquid oxygen fill and start drain back at T-minus 4 minutes, 55 seconds. That conditions the engines for launch and provides the proper amount of oxygen propellant inside the external tank for flight. At T-minus 4 minutes, the final purge of the shuttle main engines will be performed. We will start a gimbal check of the aero surfaces at T-minus 3 minutes, 55 seconds. And the orbiter will go on internal power at T-minus 3 minutes and 30 seconds. At T-minus 31 seconds, the ground launch sequencer will issue a go to Discovery's onboard computers to start their own automatic sequence. The final command from the ground computers will come at T-minus 10 seconds, which is a go for main engine start. Engine start will occur at T-minus 6.6 seconds, and we will be at 9% thrust at T-minus 3 seconds. SRB ignition will occur at T0, which will be again at 7:33 a.m. Eastern Daylight Time, with tower clear occurring approximately 7 seconds later, at which time Mission Control in Houston will take over control of the shuttle vehicle. And we're less than 30 seconds away now from resuming the countdown. Continuing to look for an on-time liftoff of 51G and its international crew at 7:33 a.m. Eastern Daylight Time. And then the ground launch sequencer has been initiated.
LPS, start the APU bus recorder.
Yes, on I see that inward.
LPS, place all fine room current plotters online.
LPS, copy.
T-minus 8 minutes, 30 seconds and counting. All systems reported go.
Houston Flight OTC, proceed with the transmission of the stored program commands.
Houston Flight, roger, that's inward.
Orbiter Test Conductor Roberto Lyric has requested that Houston send the stored program commands, which is a final update on antenna management based on the liftoff time, and sets the system, which makes the orbiter compatible with the downrange tracking stations. Orbiter AC electrical bus sensors have been placed on monitor by Pilot Creighton.
3 AC sensors in monitor.
Copy.
T-minus 7 minutes, 40 seconds and counting.
OTC flight.
T-minus 7 minutes, 30 seconds and counting. The ground launch sequencer has started retracting the orbiter crew access arm. That's the walkway used by the astronauts to climb into the vehicle. And we see the arm moving away from the vehicle at this point. It can be put back in place within about 15 to 20 seconds if an emergency arises and the crew must evacuate the pad. And we're at T-minus 7 minutes and counting. Orbiter access arm retraction is continuing. All systems reported go here in the flying room and at the launch pad 39A. Orbiter Discovery and its 7-member crew just 6 minutes and 30 seconds away from liftoff.
KRPS OTC, start your hydraulic bus recorder.
Running.
TLT OTC, perform APU pre-start.
Inward.
T-minus 6 minutes and counting. The orbiter test conductor has given Pilot Creighton a go to perform the auxiliary power unit pre-start. He'll be configuring switches in the cockpit to put the APUs in the ready-to-start configuration.
APU pre-start's complete with 3 great talkbacks.
Copy.
And Creighton reporting that APU pre-start is complete at this time. They'll be activated at T-minus 5 minutes.
DSM 1500.
That's inward.
Mission Control has transmitted the signal to start the flight recorders. The 2 recorders will collect measurements of shuttle system's performance during flight and will be played back after the vehicle is in orbit.
OTC flight.
Go ahead.
Recorders are running.
Okay, let's go for orbiter APU start.
And we have a go for APU start. LOX replenish has been terminated and LOX drainback has been initiated.
And CDR, reconfigure your heater.
Pilot Creighton now flipping the 3 remaining switches in the cockpit to start the 3 auxiliary power units. T-minus 4 minutes, 38 seconds and counting.
OTC, fuel for 1030.
Copy.
Box drain back reported in progress at T-minus 4 minutes 20 seconds and counting.
APUs up and running, OTC.
Copy.
And Pilot Creighton reporting that we have 3 APUs up and running. APU activation complete. Hydraulic pressure is reported normal, and this now limits our unplanned hold capability to 7 minutes if we should run into a problem.
Roger, in work.
The crew has been asked to close the visors on their launch and entry helmets. The final purge sequence of the main engines is underway. T-minus 3 minutes, 45 seconds, and counting. And orbital aero surface test is underway. The orbiter flight control surfaces now being moved through a pre-programmed pattern to verify that they are ready for launch.
Okay, all the engine valves look good at 4 minutes. Very good, thank you very much.
And all the engine valves are reported to look good by the shuttle project engineer. And we're coming up on T-minus 3 minutes. T-minus 3 minutes and counting. All systems are go. 2 minutes 55 seconds. External tank liquid oxygen pressurization has started, and purging of the shuttle main engines is terminated.
GLP, OTC, clear your caution warning memory. Verify no unexpected errors.
And the orbiter test conductor has asked Pilot Creighton to clear the caution warning memory system. Clearing is in work. T-minus 2 minutes 31 seconds and counting. T-minus 2 minutes 10 seconds. The beanie cap is being retracted off the top of the external tank and moved out of the way. T-minus 1 minute, 57 seconds and counting. Liquid hydrogen replenish has been terminated, and LH2 pressurization to flight level is underway. The vehicle is now isolated from ground loading equipment. T-minus 1 minute, 42 seconds and counting. We're less than a minute and 40 seconds now away from liftoff of 51G and its international crew. At T-minus 1 minute, ground launch sequencer will verify that the shuttle main engines are ready to start. T-minus 1 minute, 15 seconds. The liquid hydrogen tank is now at flight pressure. We're at T-minus 1 minute and counting. All systems go. The sound suppression water system is now being armed. Pre-liftoff water will be released at T-minus 16 seconds. T-minus 48 seconds. Solid rocket booster development flight instrumentation recorder has gone to the record mode, and the main propulsion system liquid oxygen and liquid hydrogen outboard fill valves have been closed. We're coming up on an auto sequence start. T-minus 31 seconds, and we have a go for auto sequence start. Discovery's 4 redundant computers have primary control of critical vehicle functions. T-minus 21 seconds and counting. SRB engine nozzle profile is now underway. T-minus 16 seconds. T-minus 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have booster ignition and liftoff. Liftoff of Discovery, and the shuttle has cleared the tower.
Discovery has cleared the tower at pad 39, rolling around to the proper azimuth to place the spacecraft on a 28.5-degree inclination orbit. All 3 auxiliary power units operating at 100+% of their rated RPM of 72,000 RPM. to 84 and then 65% on the main engines. As the spacecraft passes through the maximum point of atmospheric compression.
Discovery Houston, you're go at throttle up.
Roger, Houston, go at throttle up.
Throttling back up to 104%. All engines showing 104% at this time. Miles downrange. Velocity 4890 feet per second. We have confirmation of solid rocket booster separation on time. Velocity 5290 feet per second. Downrange 33 miles.
Discovery Houston, first stage performance low.
Roger, low first stage performance.
Downrange 53 miles.
Houston.
Velocity 6093.
Roger, Houston, 2 engine tunnel.
Feet per second, 84 miles.
Discovery Houston, negative return.
Roger, Houston, negative return.
Discovery now past the point of no return. Any form of abort now would mean either abort to orbit or into the transatlantic landing site, abort landing site at Dakar, Senegal. Miles, 9551 feet per second.
Discovery Houston, press to MECO.
Roger, press to MECO.
11,000 feet per second, 214 miles. engines continuing to produce 104% rated thrust.
Discovery Houston, single engine tail capability.
Roger, Houston, single engine tail.
Single engine tail means that we could go to Dakar if we were down to one engine. Feet per second, downrange 386.
Discovery Houston, single engine, press to MECO.
Roger, Houston, single engine, press to MECO.
Feet per second. Main engine's now throttled down to 85% of rated thrust. Main engine cutoff is confirmed. There will be no Holmes 1 maneuver. This is a direct insertion trajectory. There will be approximately 45 minutes from now on Holmes 2 to circularize the orbit
Will confirm
at 191
Holmes
nautical.
Required. APUs off on time.
Roger, Houston. Holmes 1, APUs off on time.
Current orbit measures 185 at apogee and 32.9 nautical miles at perigee, which will be raised by Holmes 2.
Houston, handing to Tidris in 20 seconds. You can ignore the thermal evap message on the BFS.
Roger.
Acquired by the tracking data relay satellite to 191 circular.
Discovery Houston will confirm nominal Holmes 2 targets.
Roger, Houston. Thank you.
almost 3 minutes. Almost 2 cutoff was on time, and the burn looked good according to the flight control position here. And mission control that monitors the performance of the onboard maneuvering system. Control Houston. Loss of signal through the Teeters tracking satellite. Reacquisition through Yargety in 7 minutes. Orbiter discovery currently in a 190 nautical mile circular orbit after the burn to raise apogee. This is Mission Control, Houston.
Good morning and welcome to the post-launch press briefing for the successful launch of 51G. And we have here to talk to you about it Tom Utzman, who is the Director of Shuttle Management and Operations at the Kennedy Space Center, and Bob Seek, who is our Launch Director. And we'll start with Tom.
Okay, as everybody saw, we had a very, very nice launch this morning. And again, I'd like to say it was a tribute not only to the people in the fire room, but especially to the people on the launch team who really prepared it well this time. I'd like to think that the TOW people who worked that area really responded well, and that we gave them an awfully big challenge as we're preparing the bird to send it out to Vandenberg later on this year. And they had an awful lot of work, and they responded well and finished about 2 or 3 days before launch, which was a remarkable effort. The whole team in the processing did very well, and it led up to a very clean launch with very, very few problems at all associated with the vehicle, and so we're very glad. Now, we messed it up because we did launch about 42 milliseconds late, and we're working on Bob to try to get him to improve that, but we were off at 11:33:043, so we were in pretty good shape. So the only problem I'd like to talk about, we did have one, I don't know how much it got out on the loop, we had a power problem. We lost one leg of our Florida Power and Light distribution. We have a northern leg and that comes in from the Cape Kennedy Air Force Station, and the other leg comes directly across the Indian River. Somewhere in the leg coming across the Indian River in the 115,000 volt system, we lost that power. That caused us some problems in that the plant that supplies us with our gaseous nitrogen on Merritt Island lost its power, and we were, for a short period of time, rationing our supply of GN2, which inerts and keeps our vehicles safe. Everybody responded well to the contingency procedure, and we were never in any danger, and we were able to bring it back online. And Florida Power and Light did help us, and after about an hour or so, we were able to restore power and get everything back to normal. And that caused quite a bit of excitement, and other than that and the weather, which I'll let Bob talk to, it was an extremely nominal launch.
Thank you, Bob.
Well, an on-time launch, given it was a few milliseconds late, pretty much speaks for itself. The team did an excellent job, and the shuttle system performed as advertised. And the only problems we had, other than the power, which of course we don't have any control over, was the weather. And the weather had not been too good to us lately. If you've been around here the last few weeks, it was unbearably hot. The first 10 days we were at the pad, and a lot of the team members, particularly the tile folks, had to work in that environment, which was not too pleasant. And then, of course, the drought came to an end, and in the last 5 days we've had over 4 inches of rain and some pretty exciting thunder showers last night, which did cause us to alter our schedule because of the adverse weather that we had between 4 and 7 o'clock last evening. We kept the service structure around the vehicle approximately an hour later than our procedures normally call for. And when the weather finally cleared, we turned the team loose to retract the structure and get on with the launch count. So they started out about an hour in the hole, and by the time we reached midnight, when we were to be loading the external tank per the normal timeline, we were back on time. Again, a tribute to the workforce, in this case particularly the support crews, which have to make that possible. The rest of the launch count was very smooth. Other than the power problem that Tom addressed, the whole system worked just like we wanted to and expected to in the launches which we have coming up for the rest of the year. And if you look at the agenda, we have one a month through the end of the year, and after that in the interplanetaries and the frequency increases. We're looking forward to it. I think we demonstrated on this one that the capability